built together with all the advanced level of diagnostic, and that brings down the complete commissioning, troubleshooting, monitoring, and all the physical layer FAT and SAT procedures to almost like more than 80% of the time what we spend in the normal troubleshooting can be saved. So that is the typical message. And so when we have a lot of information in the digital field, and we need to have certain type of mechanism, certain types of tools that brings back all the information back to the system. So if we have a lot of information and if it is not going properly used, and that is not going to bring any benefits to the end user. And that basically the message we wanted to deliver. So these are some of the innovations what we have done, and that brings down the complete the plant time, I mean the commissioning time, and as well as the new way of doing the intrinsic safety. It is also going to revolutionize the complete intrinsically safe hazardous area realization in the future. Okay. So I also have few slides that talks about company, but I'm not sure whether we have time. So
I don't think you have time.
Talk about that later. So thank you very much for the opportunity.
Thank you.
Thank you very much. Thank you.
I would request to call upon our next speakers from BHEL, Mr. B.S. Vishwanath, GM Engineering and Marketing, and Mr. Alok Rai Chaudhary, Deputy Chief Engineer, to give a presentation on unified DCS solutions for power plants.
Hello. I request all the speakers to be within the time limit of 30 minutes. We'll be very glad. It doesn't look good for us now to interrupt the people now saying that time is up. And there's a timer running in a small PC which starts 5 minutes before. It doesn't look good for us. After the time elapses, I will remind them after 5 minutes. I feel sorry for doing this, but kindly bear with us. Yeah, please. Yeah. Otherwise, I suggest you plan for 25 minutes so that you have 5 minutes extra for yourself. Okay. We are not curtailing anybody's speech. We are giving the full 30 minutes. Let me make it very clear. So please speak for 25 minutes. Have your 5 minutes extra for yourself.
I am Alok Rai Chaudhary from DVC. Good morning, everybody. So, it is a great privilege from me to speak before such a audience with full of dignitaries from different companies. Grateful to ARC and to BHEL. Sir, I feel a bit nervous when I see in front of me such dignitaries from different organizations, particularly some authorities of DCS are there, ED, BHEL, EDN is there, Ganapati Raman Saab is there. So if I do any mistake, please forgive me. Before I go to topic, let me tell a brief on my company, Damodar Valley Corporation. The Damodar Valley Corporation was formed in the year 1948 on this day, that is 7th July. And thank you. And this was the first public sector company in independent India. The basic mission of the company was, as you see, that flood control in the region of lower Damodar area that mostly comes in West Bengal, irrigation, generation of electricity, and its distribution in Bengal and Jharkhand, Dadin, Bihar states. Now, along with all those missions, presently our vision is to serve the people directly through different social integration programs within the 10 kilometer of Damodar Valley. Okay, in brief, it is about my company. Now let us see the power scenario of my company and how it has been related with different manufacturers. The first thermal power unit, that is first pulverized coal-fired unit of Asia, was in DVC's Bokaro plant in 1950, which is not on operation today, so it has not been included in my slide. After that, you see, from 1964, initially, we have taken units from GE and ABB, and we have started taking BHEL units on and from 1980. And as you see, that initially we have taken DCS from different other companies, Keltron and Siemens. In those days, the practice was to order the boiler turbine on EPC basis, except station C&I. Afterwards, it was a practice to give the total plant on EPC basis, except some off-site plants, that is coal handling and water system. So, in my opinion, that was the initiating point of unified distributed control system in Indian scenario. So all the DCS, wherever you see from 2005 onwards, those we are having in the unified platform of DCS. So presently we are having 5354 megawatt installed capacity and 3000 megawatt under execution and some other in pipeline. So let us take a case study of our Mejia 500 megawatt plant. Here, all the three islands, SG control, TG control, and BOP control, that is station C&I, have been implemented on max DNA system. Approximately 23,000 inputs and outputs have been dealt with by the configuration. There are 61 controllers, that is DPUs, functional groups. Although for the engineering purpose and documentation purpose, we divide it in three separate islands. But if we look physically on the network, we'll find they are all in a single network, max DNA and MaxNet. And above that, through MIS server, you are having station LAN. Now, what we have integrated? in addition to SGTG and station C&I, some off-site plants which are envisaged on PLC system have been connected to this through firewall. Now, what are the benefits? You see, this mimic diagram, we are getting the status of the total plant independent of SG, TG or BOP in a single screen. So, not only the, if I tell that we get the information, it will not suffice the advantage of unified DCS. Moreover, you can operate from the same screen any of the devices of SG area, TG area, and station C&I area without any movement to other screen. And that too with the same feeling. The operator feels the tiles are same, operation tiles, that the auto manual tiles, feelings of the auto manual tiles are same for all the three areas. In fact, in some of the units, we are having station C&I, SG C&I, and TG C&I separate islands of separate on separate platforms, and we have integrated. But a great problem in my career I faced when I was in plant operation, and even when I am in engineering, I used to listen from the operation engineers. If anything happens, whenever they find sequence of event recording, they tell me very often, फेंक दो आपका, ऐसो ही फेंक दो. काहे? बोले जो इवेंट पहले हुआ है वो बाद में आता है. In fact, the problem is we had to transmit signal of one system to other for the purpose of SOE through hardwares, or we have to take a separate SOE. Now, after this unified DCS, that problem has definitely gone. So it is another mimic diagram of the generator area. That too we get on the same screen. There is another advantage. In case of any alarm, we get alarm of all the groups in the same page. That slide is not there. Now, in brief, the advantages of unified DCS are mainly unification of hardwares and softwares, seamless connectivity between different groups of plant, seamless signal transfer from one system to another, easy maintenance, optimum inventory control, and the most important is human resource control, optimum utilization of human resource. So an engineer need not be expert of three separate systems. If one system he knows in detail, he can work in the total plant control system. Now, there are so many advantages, but then what is the issue? Why we cannot go directly to unified DCS? In this respect, I would like to draw the reference of yesterday's discussion by Siemens on field bus techniques, that is Profinet. A question was raised why it has not come in the power plant. Sir, the answer is same for this and that question. In my opinion, it is mostly dependent on the main equipment manufacturer. No turbine manufacturer allows other systems to work on, other control system to work on their turbine. So if we are to go for separate packages, then we cannot converge all the control systems in a single platform. So in my opinion, there may be a standard. A standard may be formed so that each DCS vendor must follow that standard, and the turbine manufacturers or the boiler manufacturers must accept those standards, and they cannot tell that my DCS is to be taken, if it is possible, although it requires a global solution, not in India. So I would request ARC, if possible, you may please think over it, whether it is possible universally. A standard may be formed for the control system, like TUV or anything, and every DCS controller has to follow, and the main equipment manufacturer has to accept that. Then only we can think it will be better for us if we can go for the unified DCS. So there are, in my opinion, still there is scope, future scope. So you know, in Bengal and Jharkhand area, the labor travel is much more compared to other states in India. Often we used to face labor strike earlier, and a very few officers have to run the plant. And the distance of coal handling plant, DM plant, ash handling plant would become a constraint for the limited number of engineers to run the total plant. So we started to think how it can be integrated. Now we have taken one node of control system of ash handling, coal handling, and other off-site plants in the control room. But if it is a unified DCS, these can be implemented on the same platform. What we are thinking for our next projects, some of reputed organizations in India are also doing, as far as my knowledge is concerned, in the same line. And there is another scope, particularly in the regime of LVS. Earlier, we had hardwired annunciation system in the plant. We had hard fascias. Any modification requires to change, to replace some existing alarm by another one, and it was almost fixed. Now we are very much flexible with DCS along with LVS. In the LVS, say first 3 rows are being kept for alarm. And it is a matter of one line software, you may add a alarm, any alarm. It is an advantage. But to the operator, it becomes a very disadvantageous condition particularly during disturbance of the plant. What they find, they put their maximum effort in accepting the alarms which are not so crucial at that point of time. So there is a possibility, we are working on it, for a dynamic alarm management system which will filter based on the state of the plant, and a regular audit will improve the system. So it is also further scope of unified DCS along with LVS system, and DVC is working. I think if BHEL also works in this line, then with the expertise of BHEL, C&I, and DVC's operational experience, it will be of great use to the operators in the plant. Thank you very much.
Good morning. I'll continue from Mr. Rai Chaudhary about the unified solutions and what BHEL has been doing towards the unified solution. As you are aware, BHEL is not only a INC manufacturer or a DCS manufacturer, we are also a equipment manufacturer. So I'll take you a little bit about the BHEL's role and BHEL's growth in power industry. BHEL product profile is power generation, power transmission and distribution. We are in industries, transportation, oil and gas, and also in the renewable energy. So we are a total power plant solution provider to the country. So we are a Navratna company having 15 manufacturing units, and we manufacture about 180 products in 30 major product groups, having 2 subsidiaries. So this way we are able to give the complete power plant solutions and the industry solutions to the country. So as a part of BHEL, electronics division is the nodal center for the DCS systems for the power plant, as well as we also provide equipments for the transportation and non-conventional energy and other things. So we have established facilities and expertise we have collected in the system engineering, manufacturing of modules and systems, and we also provide a very good sales, after-sales support. In fact, most of our customers, they do come to us irrespective of when the equipment has been supplied. We have been supplying and servicing the equipment, spares, and solutions to them even after 20-25 years also. Today we are supplying and we are supporting systems which were supplied by us 25 years. We are supporting about 6 different technologies of the equipment what we have supplied. Now, as Mr. Chaudhary said, the total solutions for a power plant is a unified solution. We have got a thermal power plants where all the complete gamut of power equipment, that is boiler, turbines, balance of plant, and also we are introducing the new systems called performance analysis and diagnostics, offset controls, and for hydro plants we are supplying the total auto sequence controls because these are to be remotely operated and they have to be operated in they have to be operated they have to be operated on a sequential basis, or they have to be operated on 2-shift operation like that. So the auto sequence startup is a very essential thing. Also, we have got the complete package, complete solution for the combined cycle power plants, and also we are supplying the other power related, transmission related for improving the power factor and other systems for the as a unified solution. Now, this is one of the typical example for Dadri 2 into 490 megawatt. This is one plant which has got the complete automation on a single platform, including the main turbine BTG package, offsite packages, and all the systems on this are a common package, which has got something like about 200 controllers in about 7 domains, 100 operator station max stations, and about 47,000 physical IOs and more than 500 operator displays. This is one of the biggest configuration we have done, and this is one of the biggest configuration, I think, in the power plant, where because we had an advantage, because the main equipment, boiler, turbine, everything is supplied by BHEL, so the integral part is also included, and all the offsite plants have been done. This has been done with the close cooperation of NTPC, where they took the design of the complete plant of the offsite plants and other things, so that we are able to have a model plant in the country. This is the configuration for the connectivity part of it, which yesterday's cyber security, Mr. Sarangpani was explaining about the firewall part of it, and connectivity to the internet for the remote operation as well as the plant-wide network. Then we have also implemented for the electrical systems, there's a requirement of IEC 61850 network. For that, we have the IEC 61850 connectivity for the bay control units and for the electrical systems, which is connected to a IEC 61850 client on the DCS platform. Then we have also introduced the wireless network for between the control central room and fuel oil pump house and CWPH, which have already started implementation. With this, this is an example where we have done in case of Ballari, where we have put in a demonstration plant. Now we are implementing it in major other 500 megawatt plants. We have the alarm analysis system, where the alarm annunciation system will go to alarm management system, where various factors or various inputs are taken and considered, and a root cause analysis is made, and that is displayed to the operator. So this will has got designed built on the 4 models: one is logic tree module, graphic tree module, and probability computation engine, and finally reporting engine, which gives an indication to the operator what is the likely causes of this and where he has to take action. And we also implemented the availability-based tariff on MaxDNA platform, so that they are one of the regulatory requirement in the country now. We also have established the complete connectivity to numerical relays, which are there in large numbers in today's power plants, because every electrical installation, every electrical system there is already connected to a numerical relay. The complete connectivity is brought to the DCS through this network connectivity, so that we are able to have the complete information in the main historian, as well as the connectivity and the information available to the operating people. And we have also, in the hydro area also, we have introduced performance analysis system, simulation and optimization packages for hydro power plants, and optimization software. Optimization, and we also developed a training simulator for the hydro power plant people and powerhouse intranet, so that we are able to have the optimization of the hydro resources available, so that the generation of power as per the requirement is met. As a part of the training, we are designed the complete simulator, lookalike simulator, like yesterday we were discussing about it. This simulator will be exactly similar to what is as a normal plant it is. So every plant, wherever we supply a simulator, we take the DCS part of the equipment, and we will replicate the DCS system, and we develop the models for various systems like turbine, boiler, and turbine, boiler, all the offsite plants and other things. Plus, we'll also be able to show different operating modes like cold startup, warm startup, hot startup, rolling, unit ready for qualifying. Operator can start at any point of time, and he can continue with that, and he can create various troubles or various malfunctions, and those malfunctions have to be corrected by the operator, so that he knows how to handle it in a real-time situation. And there is a instructor station. The instructor will create the malfunctions so that he can train the operator to run the plant in a proper way. Now, in addition, we have been doing it with a system called MaxDNE. Now, as the development has continued, we have now introduced a system called MetsoDNA, which is the next stage of automation, which is similar to this but has got much more additional advantages. Now the system has got a powerful, reliable controllers. All types of field buses are supported on this. We have got multi-windows functionality. We can store the pictures and desktop layouts.